Hi folks, we're going to take a look at page 21, number 20. So what they give us here is this function which represents the circulation of a newspaper with respect to time and years. Okay, what they want to know is how fast is the circulation increasing after 6 months. So first thing is to understand what exactly they're asking for. Saying how fast is this function increasing. So essentially what they're asking for is a rate of change, and they're implying here that the rate of change should be positive because here they're telling us that it's increasing. Okay, so again, while they didn't use the term slope of the tangent, they didn't exactly say rate of change, you should be able to tell by the context of the question what it is they're looking for. So what we're looking for is the rate of change. In other words, we're looking for the slope of the tangent. And so even though this question was given earlier in the course, now we can interpret that as the derivative of this function at 6 months. Okay, so earlier on you would have had to solve this using the limit definition for the slope of the tangent, which is what represents the rate of change. Now, since we have these new tools, we might as well use them. Okay, so first thing I'll do is I'll calculate the derivative of the circulation with respect to time. Okay, and that's a fairly easy derivative to take. So the 100 is just a constant. Okay, derivative of t squared is just 2t. And here 400, plus 400 is just a constant. And derivative of t is just equal to 1. And derivative of 5,000 is 0. So in the end we have 200t plus 400. Okay. Now, this is, again, you just got to be a little careful because time is given in years, and yet they're asking us for 6 months. Okay, so what we're looking for is we're looking for the derivative of c at 0.5 years. Okay, so just stick that into the equation. 200 times 0.5 plus 400, and so here we get, that's 100 plus 400 is 500. Okay. Now this again is where we're still not quite finished the problem because now all these variables have a context. Okay, so if we're looking for the rate of change of the circulation with respect to time, okay, that tells us what our units are going to be. Okay, so what this tells us is at this moment in time, the circulation of the paper is increasing at 500. Well, C is represented by number of newspapers, so it would be 500 newspapers. Okay, and with respect to time, so per unit time, which is in this case here, years. Okay, so just to recap, number one, to understand what the question was asking for, and here in reading the question, how fast is the function increasing? Okay, implies that they're looking for a rate of change. We interpret that as meaning looking for the derivative at a particular moment in time, and in this case here we just had to be careful that we were sticking with the correct units. Okay, and again, if there's a context to the question, this rate of change is expected to have units attached to it. So in this case here, since it was circulation, so number of newspapers with respect to time and years, the units are newspapers per year. Okay, I guess that should have been per year, not per years. Okay, that's it for this one.